What we want to look at today is we want to see what degree measures correspond with our radian measures. In the last lecture, you looked at how you converted the degrees into radians. So remember that going around the whole circle is 360 degrees. And we know that corresponds to 2 pi. So we know that 360 is 2 pi, and half of 360 or 2 pi, so 2 pi divided by 2 is pi. So pi right here is going to correspond with 180 degrees. If we kind of look at from 0 to pi, we know it's 180 degrees. And half of pi, which is pi over 2, is going to correspond to 90 degrees. And if you kind of add half pi onto pi, so pi plus pi over 2, okay, you're going to get 2 pi over 2 plus pi over 2. That's going to be 3 pi over 2. And 3 pi over 2 is right here. Remember that pi over 2 is 90, so when we add another 180, we're going to get 270. So 270 degrees. So these are kind of the key important ones that we need to remember when we break the unit circle up into the 360 degrees into 4 equal parts. Okay. So pi over 2 corresponds to 90, pi is 180, and 3 pi over 2 is our 270. Okay. And then once again, when you get back to the beginning, we have 0 and 2 pi. Okay. What we want to look at next is we want to look at our kind of our 45 degree angles. So let's do those in blue. Okay. So our 45, that's going to be pi over 4. Okay. And we could kind of think of it from the same perspective as going from 0 to pi. So from 0 to pi we know is 180 degrees. So if we break it up into 4 sections, so 1, 2, 3, and then this would be our 4th. So kind of here would be our triangle. So from here to here is another 90, 135, and 180. So if you break up pi into 4 equal pieces, you of course get pi over 4. Our pi over 2 from the next time, if we add another pi over 4 onto it, becomes pi over 4 plus pi over 4, which is 2 pi over 4, which becomes pi over 2. If you add another pi over 4 onto 2 pi over 4, you get 3 pi over 4. And then if you add another pi over 4 onto 3 pi over 4, you get 4 pi over 4, which is equal to pi. So we can see so far there's this interpretation of pi when we kind of divide it into 4 equal pieces, as pi being 4 pi over 4. And we can continue to do that. We could break up this bottom part right here the same way. So we know that this piece, our pi, is pi over 4. And if we break the bottom up into 4 equal pieces, we can keep adding pi over 4. Okay. So we have pi, so 4 pi over 4 plus another pi over 4 is 5 pi over 4. Okay. Add another pi over 4, we get 6 pi over 4. However, what we have down here is 3 pi over 4, and we see if we can reduce each of them by 2. So 6 pi divided by 2 is 3, and then 4 divided by 2 is 2. So we get this is the 3 pi over 2 is the equivalent. Okay. Add another pi over 4, we get 7 pi over 4. And then when we get back to the beginning, we get 8 pi over 4, which is equal to 2 pi. So once again, we have a different representation. We have the pi could be 4 pi over 4, and then this 2 pi is 8 pi over 4, which is equal to 2 pi. So let's go ahead and look at our 60-degree angles and our 30-degree angles. Let's erase this. So if we're looking at if we're starting at 0 again, and we want to get to pi, which we know is 180 degrees, we can also break this top part into 6 equal pieces. Okay? And for your reference, pi over 6. So if we break pi, which we know is 180, into 6 equal pieces, each of them is going to be equal to 30 degrees. So pi over 6 is equal to 30 degrees. Okay, so if we have pi over 6 and we add another pi over 6 onto it, we get 2 pi over 6, which we also know is equal to pi over 3 if we reduce it. Okay. Once again, if we start with 2 pi over 6 and we add another pi over 6 onto it, we get 3 pi over 6, which is equal to pi over 2. If we go on, let's add another pi over 6 because our goal is to add all the way to pi. So we have 3 pi over 6 plus 4 pi over 3 pi over 6 plus another pi over 6 gives us 4 pi over 6, which is equivalent to 2 pi over 3. Okay. And if we add 4 pi over 6 plus another pi over 6, we're going to get our 5 pi over 6. If we add 5 pi over 6 plus pi over 6, we're at 6 pi over 6, which is equal to pi. Okay, so remember with our 45-degree angles, when we broke this up into 4 equal pieces, our pi was 4 pi over 4. But now since we're breaking it up into 6 equal pieces, our pi is equal to 6 pi over 6. Okay, and we can continue. If we add another pi over 6 onto 6 pi over 6, we get 7 pi over 6. 7 pi over 6 plus another pi over 6 gives us 8 pi over 6, which is equal to 4 pi over 3, because we can just reduce it. Okay. Once again, we can add another pi over 6 onto 8 pi over 6. So it's 9 pi over 6. And if we reduce it, we see it's going to be equal to 3 pi over 2, because we reduced both sides by 3. So this is 3 pi over 2. Okay. If we add another pi over 6 onto 9 pi over 6, we're going to get 10 pi over 6. And that's equivalent to our 5 pi over 3 when we reduce each side by 2. Okay. And then if we add one more pi over 6 onto 11 pi over 6, we are going to get 11 pi over 6. And then for the last one, to get back to 2 pi, 11 pi over 6 plus pi over 6 is going to give us 12 pi over 6, which is equal to 2 when you reduce it. Okay. If we go on, so those are what happened if we divided our coordinates into 6 equal pieces at the top and at the bottom, so 12 pieces altogether. So let's go ahead and see, well, what happens instead of dividing it into 12 pieces, we're going to divide it into 6 pieces, because we want to divide the top and bottom into 3 equal pieces. Okay, so let's go ahead and look at that. So let's do that in a different color because they're going to be slightly the same but slightly different. let's try a different egg. So we'll do those in blue. So we want to divide our coordinate here into 3 equal pieces. So if you think about 180 into 3 equal pieces is going to be 60 degrees. So our first one, our pi over 3, is going to be equal to 60 degrees as a reference. Okay, so if we add another pi over 3 onto pi over 3, we get 2 pi over 3. Okay, so that's right here. And then if we add another pi over 3 onto 2 pi over 3, we get 3 pi over 3, which is equal to pi also. Okay. If we go around and we divide the bottom part into another 3 equal pieces, we're going to start at pi, or 3 pi over 3, our other name, and add another pi over 3. So when we do that, we're going to get 4 pi over 3. Okay. And then if we add on to 4 pi over 3 another pi, pi over 3, we're going to get 5 pi over 3. And then when we get back to the last one, if we add 5 pi over 3 plus pi over 3, we get 6 pi over 3, which is equivalent to the 2 pi that we had. So this is something that you should practice and kind of memorize where these units are. Make sure that you know the key ones. Pi over 6 is 30 degrees, pi over 3 is 60 degrees. Kind of the beginning one, pi over 4, was 45 degrees. So what we can do is we can use those special triangles that we learned in class with radius 1, and we can overlay them on the unit circle, which also has a radius of 1. Okay. And what we can do is we can define the 6 trigonometric functions with our triangles. Okay. So remember, the radius is the length of the hypotenuse of each of our triangles, which we said was 1. Okay. So our 6 trigonometric functions are sine. So the sine of theta is defined as the y-coordinate over the radius. The cosine of theta is equal to x over the radius, so the x-coordinate. The tangent of theta is the y-coordinate over the x-coordinate. The cosecant of theta is equal to the radius over the y-coordinate. The secant of theta is equal to the radius over the x-coordinate. And the cotangent of theta is equal to the x-coordinate over the y-coordinate. And if we look at our reciprocal identities, we see that the sine of theta is the reciprocal of the cosecant of theta. And kind of similarly, we have the cosecant of theta is equal to 1 over the sine of theta. So the reciprocals of each other. Okay, our cosine of theta is equal to 1 over the secant of theta. Similarly, we have the secant of theta is equal to 1 over the cosine of theta. And the tangent of theta is equal to 1 over the cotangent of theta. And the cotangent is 1 over the tangent of theta. Okay. And we can actually look at one of the identities here, why that works. So let's say that we have the sine of theta and is equal to y over r. And we know that the sine is 1 over the cosecant. So y over r is equal to 1 over y over r. So we're just kind of using this idea of the cosecant because it's the reciprocal. So if we multiply this out, we have 1 times r over y, which is r over y. So here, if we put 1 over the cosecant, you see that's going to get that same identity that we had here, r over y.